Okay, first let me introduce myself. My name is Aisyah Salsabila from the Institute of Technology Sumatera. My major in biology. Here I will explain my final project about social innovation design for advancing the triple point or top for a village innovation future. Then I will describe the overall picture of this project. In general descriptions, Pugung Raharjo Village faces environmental pollution due to direct discharge of tofu wastewater into irrigation channels. This project offers a solution to bioremediation using EM4 and phytoremediation with aquatic plants such as water, hyacinth, or Hydrilla, supported by additional fermentation materials like palm sugar. Within 14 days, the waste is processed into liquid organic fertilizer or LOF that benefits local agriculture. Community education is carried out in two stages: raising awareness on waste hazards and sustainable economy, followed by technical training on fertilizer production. Next, I will explain its objectives. One, to assess the impact of tofu wastewater on environmental quality and public health in Pugung Raharjo Village. To implement bioremediation techniques used as an environmentally friendly method for converting tofu waste into liquid organic fertilizer. To raise awareness and encourage behavioral change among the community to manage household and small-scale industry was more responsible. To provide education to residents about the concept of circular economy and the added value potential of creative and productive waste management. To offer sustainable solutions through the use of simple technologies adapted to local conditions, aiming to maintain environmental clean lands and support agricultural productivity. And the problem formulation about 1. To what extent does tofu production was affect the quality of irrigation water, the surrounding environmental conditions, and public health in Pugung Raharjo Village? 2. How can the application of bioremediation methods be utilized to process tofu waste into useful products such as liquid organic fertilizer? 3. What efforts can be made to raise awareness and change community behavior in managing waste through a circular economy approach? 4. How do environmental education and community empowerment contribute to long-term solutions to the tofu waste problem? Okay, now let's move on to the discussion of this project. Expected outputs. This project is expected to generate several tangible outcomes for the community of Pugung Raharjo Village. First, it aims to reduce fall odors and pollution caused by tofu wastewater in local irrigation channels. Two, second, the treatment process is expected to produce liquid organic fertilizer that can be utilized directly in local agriculture. Third, the community will gain increased awareness and knowledge through educational activities focused on sustainable economic practices derived from waste management. Furthermore, the program aspires to establish a self-sufficient and sustainable fertilizer production system that can be continued by local residents even after the project ends. Ultimately, this initiative is intended to serve as a foundation for future environmentally educational programs in the village, particularly in promoting eco-friendly agriculture practice. Next, specific village concerns. There inadequate environmental sanitation resulting from the direct discharge of garbage into irrigation canals. 2. Insufficient community awareness and engagement in garbage management. 3. Lack of a straightforward and cost-effective waste treatment method for small industry. Next, material and tools required needed. Materials needed: 1. Liquid effluent from the tofu production process. 2. Active EM4 or effective microorganism. 3. Burnt sugar if needed. Fermentation activator. 4. Clean water, distilled or well water. 5. Aquatic plants, water hyacinth or Hydrilla. Tools needed: fermentation vessel, phytoremediation, open pond or tub. pH measurement instruments, around 6 or 6 until 7 standard normal. Next, personal protective equipment, filtration apparatus, packaging and education materials, banners or leaflets for community outreach if necessary during socialization. Next, estimate timeline. Day 1, sales survey and identification of top producer. Day 2, initial community outreach and education. Day 3, technical training on bioremediation and phytoremediation. Day 4, mixing was with EM4. Day 5, planting water hyacinth of Hydrilla. Day 6 until 11, fermentation and phytoremediation process. Day 12, harvesting liquid organics fertilizer. Day 13, LOF distribution and mini educational expo. Day 14, initial evaluation and village reflection. This needs 2-week timeline. 2. Synergy of the 4 outputs. 1. The prototype generates empirical data which is then presented in a paper after journal article. 2. The module documents the prototype's standard operating procedure or SOP. facilitating training and standardization. 3D video translates the module into a visual format, broadening we broadening the research, the ritual education for the impact journal combined with video or module documentation forms an evidence-based package that helps convince the local community to support the sustainability of the project. Okay, thank you. The expected outcomes include a reduction of irrigation water pollution by up to 60%, production of 50 or until 100 liters of liquid organic fertilizer per month, an increase in crop yields by around 15%, an increase in tofu entrepreneurs' income by at least 10%, and the realization of an educational tourism destination based on environmentally friendly agriculture. Okay, thank you for the minute. Stop acceleration for future growth on rural innovation. Thank you and bye bye.